Solve each quadratic equation by factoring. In our first example, we have the equation 8x squared plus 2x equals 0. These two terms have a 2x in common. If you divide 2x out of both terms, you will have 4x plus 1. You can check your factoring by remultiplying. That would be 8x squared plus 2x. Once your factoring is done, take each factor individually and set equal to 0. This first equation, 2x equals 0, divide both sides by 2, and you will get an answer of 0. The other factor, set equal to 0, subtract 1 from both sides. That leaves 4x equals negative 1. Divide both sides by 4, and you will find x equals negative 1/4. Most times, many times, a quadratic equation, which has a power of 2 as its dominant term, will give you two solutions. And this one's true. 0 and negative 1/4 both will satisfy the original problem if you check it. The example to the top right, we have a trinomial quadratic equal to 0. When we factor, we need to find a pair of numbers that have a sum of 4 and a product of 4. In class, you guys told me to use a positive 2 twice, which was great. 2 plus 2 is 4. 2 times 2 is also 4. Because these factors are identical, you only need to take one of them, set equal to 0. Solving for x, you get negative 2. In our next example, top left, we have 16x squared minus 25 equals 0. That is a difference of two squares, and you can factor that by taking the square root of each term, which will be 4x and 5, and then throwing in a plus and a minus sign. The order of those don't matter as long as one's positive and one is negative. Setting each factor equal to 0, 4x plus 5 equals 0, subtract 5 from both sides, divide both sides by 4, and this first factor is equal to 0 and x is negative 5/4. Take your second factor, put it equal to 0. Solving for x, we add 5. 4x equals 5. Divide by 4. X equals 5/4, and that's your other solution. Those are the two answers to that original quadratic equation. This upper right equation, negative x squared plus 5x equals 6, this one is not set equal to 0, and typically with quadratic functions, quadratic equations, you want to put all your terms on one side. And so that's what I've done here is I have moved negative x squared to the right side of the equation by adding it to both sides. Since there aren't any x squared terms on the right side, there's nothing to combine with it. So basically you move it over, change the sign. 5x, same thing is true. When it moves across the equals, it becomes a minus or a negative 5x. This 6 stays on the right side of the equals, so I just scooted it down and made sure it stayed positive. We have another trinomial. This can be factored if you can find two numbers that have a sum of negative 5 and a product of 6. In class, you guys told me to use a negative 2 and a negative 3. That's a great selection. If you add negative 2 and negative 3, you get negative 5. If you multiply those two numbers, you get positive 6. Great job, y'all. Set each factor individually equal to 0. Add 2 to both sides. One of your solutions is 2. Then the other factor is equal to 0 when x equals 3. That's your other solution. A specific type of quadratic equation is one that uses a technique called extracting square roots. If you ever have the format of an equation where you have something squared equal to a number, you take the square root of both sides, including the positive and negative square root. X equals positive and negative square root of 169. which is the same as positive and negative 13. These are the two solutions to that equation. If your equation is close to being in the right format, but it's not quite there, like for example in this one, if we divide both sides by 2, we get x squared equals 18. Now it's in the proper format to extract square roots. Take the square root of both sides. Don't forget the positive, negative. The plus minus is also to preserve the fact that there are two solutions. Positive and negative square root of 18 are the solutions to this equation. If by chance you're asked to reduce, this one is reducible because 18 has a perfect square factor of 9. 18 can be written as 9 times 2. Square root of 9 is 3. This 2 stays underneath. So a reduced set of answers will be positive 3 square root of 2 and negative 3 square root of 2. And finally, a third example of extracting square roots. We have the right format. We have something squared equal to a number, so we take the square root of both sides. When you lose your square, you pick up a plus minus. X minus 6 is the something being squared, so we have x minus 6 equals positive and negative square root of 36. Square root of 36 is 6, so we have plus minus 6. Because we don't have x isolated and we do that by adding 6, be very careful that at this stage of the problem, if there's anything you have to move over to isolate x, that when you move it, you change the sign of it. So that minus 6 becomes a positive 6, but tuck it in front of the plus minus term. That way, when you get ready to separate and write your two solutions, your plus sign will cover one of the answers, 6 plus 6 is 12, and the minus will cover the other answer, 6 minus 6 is 0. These are the two solutions to your equation. And then finally, we're going to investigate how many solutions to expect from a quadratic equation. That's called the discriminant. The discriminant does not give you the solutions, it just tells you how many there are. In our first equation, all of our terms are on one side equal to 0. And look down here in the magenta color, for any quadratic equation, ax squared plus bx plus c, you identify the values of a, b, and c from your problem, and then your discriminant is b squared minus 4 times a times c. Many of you will recognize this as what's underneath the square root in the quadratic formula. When we cover quadratic formula, I will re-mention this because it's all intricately woven together. Once you've identified a, b, and c from the original problem, make sure it says equals 0 before you identify those three numerical values. Then you can calculate your discriminant, your b value squared minus 4 times your a value times your c value. Negative 3 squared is 9. These two will make a positive 4 times 1 is 16. 9 plus 16 is 25. Since this discriminant is positive, we can expect that equation to have two real solutions. In our upper right equation, we have another quadratic equation. X squared doesn't specifically have a number written. If that's the case, it's an understood 1. Our b value is negative 4, and our c value is positive 4. All terms are on one side, so we've correctly identified a, b, and c. Calculating your discriminant, we take our b value, square it, minus 4 times our a value times our c value. Negative 4 squared is 16, minus 4 times 1 times 4 is 16. We have a discriminant of 0. If the discriminant has a value of 0, there's only one real solution to your quadratic equation.